Welcome to Math with Mrs. Seeley. This is an ACT strategy video useful when attacking word problems. I will show you how to write out your thought process, making these types of problems easier. And don't forget to hit that like and subscribe button if you find this video helpful. Let's begin building your ACT score one problem at a time. Looking at number 19. It says Lodo begins at his back door and walks 8 yards east, 6 yards north, 12 yards east, and 5 yards north to the barn door. About how many yards less would he walk if he could walk directly from the back door to the barn door? Well, what we want to do here is we just want to draw a diagram. Let's draw out what's going on here. So here he is and he starts. He's going to go 8 east, 6 north, 12 east, and 5 north and get to the barn door. So let's label that. We said 8, 6 north, 12 east, and then 5 north. The question says, how many yards less would he walk if he could have just taken a straight shot? So if he had started here and just taken a straight shot, how much less would that have been? Well, when you're doing these types of problems and word problems in general, sometimes content gets involved, and that's something that's happening in this problem. Does your mind see these as right triangles where we could use the Pythagorean theorem? So there is some content on this one. So let's find this. So we know a squared plus b squared is equal to c squared. If you go to your calculator or in your mind really fast, add 8 squared plus 6 squared, and you get 100 is c squared, which means c is 10. So that distance is 10. Do the same thing. Let's use the Pythagorean theorem on this one. And 12 squared plus 5 squared is equal to c squared. Add that up real fast in your mind, or just go to your calculator and say 12 squared plus 5 squared, and you get 169 is c squared. Take that square root, and c is 13. So we find out if he could have walked straight to the barn door, he would have walked 23. Now be careful because they have that as an answer, but it's not our answer. Read careful. It says how many yards less would he walk. So what he actually did walk was 8 plus 6 plus 12 plus 5. So he did walk 31. He could have walked 23. Subtract how much less, and your answer is A. Okay, let's take a look at the next one. The length of rectangle A is equal to the length of rectangle B. The width of rectangle A is 3 inches less than the width of rectangle B. If it can be determined how many inches less is the perimeter of A than B. All right, well, let's kind of draw this out again too. So I've got a rectangle A. We'll call this A. And we got a rectangle B. It says that the length is equal. So we know whatever this is, which it's the same on both sides because it's a rectangle, we know these are the same. But we're told that the width of A is 3 less. So this width is 3 smaller. And that would also be 3 smaller because in a rectangle, those are the same. Now the question says, what about the perimeter of these two people? Well, perimeter, and here comes some more content that you would need to know perimeter. Perimeter is around the edges. It's around the edges. Maybe you've heard someone say, I need to secure the perimeter and make sure things are safe. That means they want to walk around the building or the house and just make sure everything's okay around the edges. So if I'm looking at this perimeter over here, and those are the same, but that's 3 smaller and that's 3 smaller, so wouldn't that be a total of 6 smaller than the other one? So my answer is G. Okay, let's take a look at 25. In the diagram below, B, F, and H are on AC, AE, and BF, and you can see that. It tells us GH is perpendicular. I can see that. There's that right angle. It says the area of square ABGF, this right here, is 1/4 of the whole picture, which I would trust my eyes and see that that's the case. And then the question says, so what is this triangle right here, FGH, to the whole square? So this right here, this triangle, what is it in relation to the whole thing? Well, let's just kind of break this up into parts. So we know they told us, but we were going to trust our eyes anyway, that that's into force. All right, let's just try to recreate right there. And then we'll do this. So we're just going to break it up and this. And we want to know how much is the yellow triangle in relation to all the other triangles. Well, let's just count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the yellow one is just 1/16. So that's just a strategy. We just want to break it up into smaller pieces. Look at number 14. What is the largest possible product? And remember that product means to multiply, for 2 even integers whose sum, and that means add up, to 50. So they tell us that we're going to have 2 even integers whose sum is 50. So we're going to have to kind of list these out. So I could say 2 and 48. That's 2 even integers whose sum is 50. But I could also say 4 and 46. That adds up to 50. And so does 6 and 44. And so does 8 and 42. All of these total or sum up to 50. Then I could have 10 and 40. Do you kind of see the pattern? These numbers are going up by 2, and these are going down by 2. So you could just keep going. So then we could have 12 and 38. That adds to 50. 14 and 36. 16 and 34. 18 and 32. 20 and 30. All right, then we'll have 22 and 28. 24 and 26, and then I would say 26 and 24. But haven't I started to double up? So really, I just need to do half of them, and it takes a little second, but it's real easy if we'll just list these out. So then we know that we're going to stop with those. Those are the sum of 50, but the question says, what's going to be the largest product if I multiply those? So if I go to my calculator and I say 24 times 26, I'm going to get 624. Now, first of all, I could go look and see that of my answer choices, 624 is the largest number on the page. Nothing's going to get larger, so I know that's my answer. If I did keep multiplying, say you didn't see that, and you kept multiplying these numbers out, what you're going to see is that they're getting smaller. The numbers are just getting smaller. So definitely that's my answer. Okay, look at number 32. Number 32 says this. It says, Ashton, Olivia, and Jane are standing on a soccer field such that Olivia is 20 meters due west of Ashton and Jane is 40 meters due north of Ashton. Do you notice that everybody is defined in terms of Ashton? Olivia is 20 meters west of Ashton. Jane is 40 meters north of Ashton. It says their positions are the vertices of a triangle. Which of the following gives the degree measure? So it looks like there's going to be some content on this one too. We're going to have sine, cosine, and tangent or SOHCAHTOA. Let's draw a picture. Let's write out our thought process. Remember, everybody is defined in terms of Ashton. So I'm going to let A be Ashton. Olivia is over here, 20 meters west. Jane is 40 meters due north. And it said we have a triangle. The fact that it's due north and due west is what makes this have to be 90 degrees. And also I know because sine, cosine, and tangent are there. So I know this is a right triangle. Now let's think about our relationship. Do we have sine, cosine, or tangent? All right, here's the reference point where Olivia is at, from where Olivia is standing. This is the opposite. It goes to the opposite side. Think if you were going to go to the opposite side of the street or the opposite side of the table. This is the adjacent. It's who you're sitting next to. Now, I know this would have been the hypotenuse because it's across from the right triangle. So I don't have that. So I've got opposite and adjacent. I've got TOA, opposite and adjacent. So I know my answer has to be J or K. And then just do the right ratio. Opposite over adjacent, 40 over 20. As a side note, if you need more practice with SOHCAHTOA, I've got 2 different videos, content videos, on the channel if you need a refresher on that. All right, let's take a look at number 29. One side of a square, ABCD, has length of 12. So we've got a square whose sides are 12. Then we have a rectangle who has the same area of that square, whose width is 8. What is the length of the rectangle? Well, let's just draw out a picture. We've got a square. Just take it one little baby step at a time. The sides are 12. Then we have a rectangle. It says the area of the rectangle is the same as the area of the square. So the area is length times width, or base times height. The area of a square, you could say sides squared. Maybe you learned it that way. Maybe length times width, maybe base times height. Regardless, you're just multiplying the 2 sides. So that would be 144. That's the area. But we know that the area of the rectangle is the very same thing. So if this area is 144 and this area is 144, and we were told that the side is 8, and we want that, well, just think to yourself, what times 8 gives me 144? You might divide that, or you might just work backwards. Okay, let's take a look at number 24. Nora invited 4 friends to play table tennis. Each of the 5 people at the party played every other person just one time. The table below shows the number of games won by each player except Nora. There were no ties. So how many games did Nora win? So to find out how many games Nora won, I would first of all need to know how many total games were played so that I'll know how many are left for Nora. All right, so let's think about this. It says each person played every other person one time. Let's see if we can't list out these games. So Collier played Evangeline. Collier played Gabe. Collier played Nora. Collier played Maria. Okay, so we've got Collier playing every other person. Now what about Evangeline? Well, Evangeline played everybody and already got that Collier, but Evangeline played Gabe. So what we're doing is we're just getting all our possibilities. Evangeline played Nora, and Evangeline played Maria. Okay, now let's go to Gabe and all the people that Gabe played. Well, Gabe played Collier, already got that. Gabe played Evangeline, already got that. Gabe played Nora, and Gabe played Maria. And then lastly, what about Nora? Nora has already played all of those. I've listed those, but I haven't gotten Nora and Maria. So then count it up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There were 10 total games that were played. Right now I've got 2, 3, 4, 5, 6, 7. So that means 3 games left. So Nora won 3 games. Okay, last one. During rehearsal for the Founders Day choir program, the director tried 3 different configurations, each using all the choir members at the rehearsal. One configuration was to have rows of 12. Another configuration was to have rows of 15. Another configuration was to have rows of 20. But none of those configurations worked because for each one, all of those different possibilities, the last row had 1 person less than the other rows. What was the least of the possible numbers of choir members at the rehearsal? The first time I read this question, I was kind of thinking, how am I going to approach this? But there have been so many questions on the ACT where you have to list out multiples of things. So I went with that first. So I thought, okay, rows of 12. I'm just going to start listing out multiples of 12 people in a row. So 12, 24, 36, 48, 60, 72. And if I need some more, I'll go get some more. All right, then the rows of people with 15. Well, 15, then 30, then 45, then 60, then 75. And if I need some more, I'll get some more. And lastly, 20. 20, 40, 60, 80. We'll get more if we need them. And again, this is a common concept to list out rows. So you'll see several different types and styles of problems where you're going to do that. That's what gave me the idea to do it this time. So I was looking at this and I realized, you know what? 60 is in common with all of them. But guess what? 60 isn't one of my answers. And then I remembered, wait a second, look at that yellow highlight. A person less? Well, if 60 is the same, take 1 away from 60, and 59 is my answer. So this is one of those problems where I just kind of stumbled across the answer. I wasn't sure where it was going to go from the beginning, but I just started writing out my thought process and just stumbled across that answer. And it's all right. Sometimes that's how it works on the ACT. If you'd like more help with content or strategy, be sure to check out the other videos on my channel. And don't forget to hit that like and subscribe button and also share and tell a friend about ACT Prep. See you next time.